All right, so today we're going to take a look at the first part of section 9.2, which is going to be on polar graphing. Today we're really just going to look at some of the real basic stuff, so we're not even going to get into graphs. We're really just going to look at individual coordinates today. How do you graph an individual point in polar? How do you change a point in polar back to the kind of system we're used to, which is an XY axis, and some stuff like that. Has anybody worked with polar coordinates before? No? All right. So up until now, even with parametric, that's a rectangular-based system, meaning every coordinate has an x and a y value. Movement is left and right, and then the second movement is up and down. And that's done on a grid. It's y-axis, rectangular or square graph paper. Well, some types of curves, it's a lot easier to draw them in polar. Okay? And I mentioned one type of curve that's super easy to do in polar, and that's a circle. Yesterday I showed you how difficult it is to draw a circle as y equals. You need all that square root stuff. And if you remember, the circle didn't even connect. I kind of drew the top part and the bottom part, and they didn't really meet. So that was kind of a pain. When we did it in parametric, it was a much more elegant formula. Okay, it didn't have any square roots and squares and things like that. All we had to do is, if we wanted a circle with radius 3 at the origin, we do r cosine t, r sine t. And that's it. If we do zoom square, we get a nice looking circle where the sides actually meet. I don't have to draw it as a top half and a bottom half separate, and it looks good. So that was in parametric. So just kind of look at all, what I had to type in to do it in parametric, better than a function. But in polar, I can do it even easier. If I want to graph that in polar, okay, you can see what I have there. If I go to polar, changes again. Now the screen says r equals, because we're going to be dealing with radii. I type in 3, and that's it. I type in one number. So to draw a circle in polar, that's the entire equation, r equals 3. So really, really good for circles where it comes in. What's kind of hard to do is lines. Okay, if you want to draw a line in polar, it's kind of a mess. Much, much better to draw a line using y equals mx plus b form. That's by far the easiest way to do a line. Okay? But we'll look at a line in polar if we have a little time. Okay, so there's the kind of graph paper you use when you're doing polar. Notice the screen doesn't show that. It doesn't show this grid behind it. It still draws it, almost like there's an XY axis there, but you have to pretend like there's concentric circles behind it. Even if you turn the grid on, turn on the grid lines, it's not going to show concentric circle grid lines. It's going to show grid lines like you're used to. Okay? And that, to me, is a little confusing because really polar is on a different kind of paper. It's not on that. Okay, so I'm going to shut that off so we don't have to look at that. Okay, the pole, it's called, this is the origin. Okay, same thing. Pole, origin, you can refer to it either way. And a coordinate in polar doesn't use an x and a y value because we don't talk about x and y axis anymore. We talk about a radius and an angle. So in polar, you can move out a certain distance from the origin. And then once you do that, you can move a certain amount of degrees. Now, for each one of those, there's two directions. If r is positive, we're going to go one way. If r is negative, we go the other. If the angle is positive, we go one way. Negative, we go the other. So we'll talk about now which way you go when it's positive, which way you go when it's negative. All right, so if r is positive, you're going to start at the pole. or the origin, and you move to the right. So it's kind of like what you would do on the x-axis. It's kind of the same thing. You start at the origin, and then you move right. If r is negative, start at the origin, and you move left. How many units? Whatever r is. Okay, you move that many units. And just like with a grid, you can have decimals. So let's say r was 4.5. Well, if I go back to that concentric graph paper, I go out 1, 2, 3, 4.5 units. Now that wouldn't be the answer. That's the starting point. Okay, so that's like if you're graphing a coordinate, you've done the first part. You did the x. Now we got to do the y. Okay. We did the r. Now we got to do the theta. That's what we call it in polar. Now, angle is movement on a circle. So when we're moving circular, we don't really say left, right, up, and down. What are the two directions you can move that are circular? Yeah?
Clockwise and counterclockwise.
Right. So from this point, we would either move clockwise or counterclockwise. Depends on the angle. So if it's greater than 0, we're going to go counterclockwise. If it's less than 0, clockwise. And remember, this is all done from where you ended up after step 1. Okay. Just like if you were graphing an xy point. You do your x value, and then from that spot, you do your y. You don't start over and go back to the origin. Okay, so what we'll do is we'll look at all the different kinds of things that could come up. Both positive, both negative, one of each, 0. And just practice graphing all those points. And then I'll explain something that happens in polar that doesn't happen in xy coordinates. Something that's kind of a totally different idea. And then the last thing we'll do is we'll look at conversions. How do we change a point that's r theta back to xy, and then the other way? Okay, so let's start with graphing the point 345. Okay, what you could do, I don't have any polar graph paper. You can get it, it's online. But what you could do for the homework is if you draw one grid, then you could just label each problem from the homework, and you don't have to keep redrawing the same grid. So just label your problems like that. If anybody really wants polar graph paper, let me know. I can print out some polar graph paper. It's easy enough. Okay, so 345. So let's start with our radius. Shauna, what's my radius here?
3.
Yep. Radius is always the first number. And it's telling me to move 3 units from the origin. And which way do I move? To the right or to the left?
The right.
To the right. So I'm going to put a little X there. I'm going to erase that in a second. But that's just to remind me, okay, I'm going to start from there. And now I'm going to go 45 degrees. But I have to decide if it's clockwise or counterclockwise. Counterclockwise. Okay, just to clear this up. If you're going that way, that's counterclockwise. If you're going that way, that's clockwise. Okay. So counterclockwise, 45 degrees. Just try to make it as accurate as you can. This one should be right in the middle. So if you want to draw that dotted line to help you, you can. You don't need to. And there's your point. Some graph paper, if you actually use polar graph paper, they already have the divisions on it for you. So these are divisions of 15, 0, 15, 30, 45, 60, 75, and then 90 is straight up. So that is one nice thing about having graph paper. You can be a little more accurate. So on a test, if you put it right there, that's perfect. If you had it down here, I'd probably give you half credit because you're on the right. You're the right radius from the origin, but you're not really near 45 degrees. I would think that's more like 15, 20 degrees. It's not 45. Okay. Any questions on that one? Let's look at this one. Negative 275. So we still got a positive angle, but this time negative radius. So Gracie, since my radius is negative, what am I going to do different this time?
To the left.
We're going to move to the left. How many? 2, because r is 2. So we're going to start from that spot. Again, you don't need to mark that. I'm just putting it there so you know where to start. I'll get rid of it in a second. And now, Jayan, I'm going to move 75 degrees which way?
Counterclockwise.
Counterclockwise. All right, so I'm going in that direction. Where would 75 degrees be? Would it push me outside of quadrant 3? No, it's going to get me close to 90, but a little bit short. Because if I went all the way to here, that's 90. So just go a little before it. Okay, halfway would be 45, but we're 30 degrees past halfway. So to me, that looks reasonable. Any questions on that one? Okay, so that's a negative radius, positive angle. Let's try a positive radius, negative angle. All right, so Megan, what would I do first? Yeah, we're going to move right 3. So we're going to start from there. And now, Leo, I know I'm moving 60 degrees, but which way? Clockwise. So clockwise, it's not going to get us out of quadrant 4. It's going to get us 2/3 of the way through the quadrant, because the whole quadrant is 90. So what I would do is go about halfway, and then hopefully that looks like it's a little more than half. Yeah, I think it does. Okay, any question on that one? From the side, the perspective is very different than when you look at it from the front. If you wanted to maybe go a little more, you go a little more, but I think it's pretty good. Questions on that one? All right, so we got positive, negative. Now let's look at a negative, negative. Okay, here there's something you might want to do first if you're not comfortable with the way it's written, but that's up to you. What's a little different about how this one is written? Yep.
It's written in radians.
Right. The angle is in radians. So if we wanted, we could change it to degrees. And for most people, they have an easier time kind of visualizing where things go in degrees. So what's negative 3 pi over 2 in degrees? Yep.
Negative 270.
Yep, negative 270. Whether or not it's a good idea to change it to degrees, I don't know if it's really going to help you in the future, because when you take calculus, you just have to know radians. If you have to change to degrees every time you're doing things in calculus, it's going to really complicate your life. But for this type of thing, if you wanted to, you could. All right, so we're going to start by going 4 units left. And now negative 270. Abby, which way do I go for negative 270?
Counterclockwise?
I'm going to go counterclockwise. Wait a minute, let me think for a second. Negative angle, no, clockwise. Okay, negative angles go clockwise. Sometimes when you go to the left, you got to think about it a little bit, because just follow the 2 rules I gave you. So where am I going to end up if I go 270 degrees clockwise? Yeah.
90 degrees counterclockwise.
Yes, it would be 90 degrees counterclockwise, which is just going straight down. Yeah. And I'm going to mention what you just said in a second about there's different ways to get to that point. So that's one way, negative, negative. Now, Megan just said something about going clockwise or counterclockwise. Let's see if we can write it that way. So if I had, let's see. Let's do something with 90. Anyone think they could give me directions on how to get to that point? And this time I'm going to let the angle be 90. Yeah? Yeah, this would still be -4 and 90. So what we're doing this time, I'll draw it in different colors. -4, 90. Okay. The one I did in black, that was -4, -270. All right, let's do it again. Can someone give me another way I could get to the same point? Yep, kidding.
+4 and -90.
+4, -90. Okay, let's try that. +4, -90. Yep. And let's do one more. Yeah.
+4 and 270.
+4, 270. +4, 270. So you can see there's 4 different ways to get to that point. Okay? So every point in polar has 4 basic ways to get to it. Now you could say, well, couldn't you do something like this? Go right, go around, keep going, and then stop? Yes, but that's just a repeat of one of the others. You went right and you went counterclockwise. Okay. How many times you go counterclockwise, that doesn't matter. Okay. The reason I show you this is because if you get an answer to a problem on a test, okay, so let's say you have a point like this, XY point, and I ask you to convert that to polar. You might get a certain answer, but keep in mind there's 3 other ways to write that answer. So if it's matching, maybe you got the answer in red, but the answer on the test is the one in blue. I went with positive, positive. So you just have to know how to get these different answers. The easiest way I think to do it is to draw it and look. If you want, you could probably come up with formulas like, if you keep the radius positive, just add or subtract 360. Okay, in this case, add 360 to -90 and you get 270. So you could try to come up with all kinds of shortcuts to do it, but the easiest way is probably just to sketch it. So any questions on that one? All right, so we've done all the different combinations, positives, negatives. Let's look at 0. Okay, so 0, pi. Where is that point going to be? Yeah? It's at the pole, but what about the pi?
Well, if you don't have any distance, the angle wouldn't matter. You'd still be in the center.
Right, you're still going to be at the center. So what you want to do to draw this one is you put it at the pole, because the radius is 0, and then pi is 180 degrees. So you just take your point, and you just rotate it, just like that, 180 degrees. Right? Make sure you rotate it. No, I'm kidding. People are looking at me like I'm crazy. You can't really tell. So on the test, I'm just going to look at you spin your pencil in place kind of thing. But just 180. Don't go 270 or anything like that. Don't be crazy. So that's a 0, anything is always at the pole. It doesn't change. If we switch it, make it something, 0, that's a little different. Is that going to be at the pole? What do you think? Yeah? No, that's not at the pole. It's basically on the horizontal. All it's going to do is move left or right. In this case, it's 2.5 units to the right If it was negative, you would go left, but the angle is 0, so we don't move off that horizontal axis, which sometimes they call the polar axis. Okay. So any questions on that one? Yes?
So how is that point different from like when we put in our calculators and just put a radius of 3 to make the circle? How would you
graph a point?
Well, no, because like when we first switched to polar,
Yeah.
we just put r equals 3 and it graphed a circle.
Right.
Wouldn't that just be r equals 2.5?
So r equals 2.5 is kind of like, if you did this, what this means is 2.5 comma anything. When you say r is 2.5, it's kind of like if I said to you, graph the line y equals 2. Well, for that, it could be, x could be anything. You just have to make y 2. So r equals is every single point with a radius of 2.5. This is just one specific point with an angle of 0. Does that make sense? Okay. So there really is no way to graph a point on the calculator. Same thing in xy. You can't really plot a point. Now, you can kind of cheat if you go to second draw. And I forget, oh yeah, you go to point. You can basically turn an individual pixel on the screen on and off if you want. You just have to specify the location of the pixel on the screen. But that's not really graphing a point. That's just, you can just turn one of the pixels on the screen. And you can turn it on any color you want. So sometimes when people make a drawing, that's how they do it. You can turn individual pixels on and off. You can also save, I think it's JPEG pictures in here. And when you save a JPEG picture and then set it as your background, okay, and bring it up, it's not really mathematical equations creating that background. It's just a bunch of pixels turned on and off the right colors to make it look like your picture. There's no math equations. But sometimes what people do is they put in like a background, like maybe you had like an arch of a bridge or something, and then on top of that arch, they try to find the equation of the arch in the background by using a parabola. And you can kind of do that on the calculator. We don't really get into that, but you could. It would be kind of handy actually if there was a camera on the calculator. No, actually I wouldn't like that at all. But if you did have one, you could just like hold it up to like, you know, a doorway or something, or a bridge or whatever, get the picture right on the screen, and then you could kind of measure things and calculate equations of stuff. Of course, phones can probably do a lot of that now too. Okay. So any questions on that one? All right. That's just another positive. I'm not going to go through it, but the point I was going to show you is when you move 180, it doesn't really matter which way you go, because 180 is halfway around. So this one would actually be right 3, 180. But if you accidentally went negative 180, you'd still get to the same spot. But you should know which way to really go. All right, so I've already explained that in polar, there's more than one way to graph a point. And that doesn't happen in rectangular. Okay, if I bring up a rectangular grid, or just kind of quickly sketch something, and I ask you what the coordinates are for that point, there's one and only one way to get to that point. It's 2, 1. It's not like you can say, oh, well, it could be 2, 1 or 2, negative 1. No, there's only one way to get to that point. But in polar, that's not true. Now, some people get kind of like, they start really thinking about it deeply. Bring this up to Mr. Babb and see what he says. But if you think about r is a distance. So how can r be negative? Like, what does it even mean to say you have a radius of negative 4? Does that even make sense? And the way I think of it is, I think of this as the radius. I think of that as the direction. So I think of that as a directed distance, not a negative distance. Directed. So negative means it's left 4 instead of right 4. Mr. Babb doesn't completely buy that argument, but don't think about it too deeply. Just go with what I showed you. If you want to get in a good argument with him, bring it up. It messed up his whole weekend once, he told me. Like the whole weekend was shot because he just thought about it. Couldn't get his mind around that. All right. So the last two things we're going to look at is how we can convert a point from polar to rectangular. And then I think we're also going to do rectangular to polar. All right. So in polar, a coordinate is set up how? What are the two things they give you in polar? Yeah. They give you an r, they give you a theta. And in rectangular, which is the kind of grid that we use with parametric and function graphing, what do you have to have for that? You don't want an r and a theta.
X and Y value.
You want an x and a y. So that's the whole goal of this, to turn an r and a theta into an x and a y. So, and I'm guessing a lot of people could probably kind of figure out how to do this. So I'm just going to put a single point right there, and that's going to be a point in polar. So I would know that distance right there. That would be r. And I would know theta. I would know those two things. My goal is to figure out the x and the y. So what do you think I'm going to do or add to this picture? Yep.
You're going to make it a right triangle.
Yeah, I'm going to make it a right triangle. And the way we're going to do it, just going to drop a perpendicular straight down. There's your x. So you have to find out how long that is. It's the base. And there's your y. That's your height. As long as you know this and that, you can find either one of the other things. Let's start with x. What trig function would I use to find x? Yeah?
Cosine.
Cosine. So we would set up cosine of my angle equals adjacent over hypotenuse. So the formula for x would be what? Yeah.
R cosine theta.
Right. It's r cosine theta. And what about the formula for y? Yeah.
R sine theta.
R sine theta. Haven't we seen that before? We did the equation of a circle in parametric form. What's different about this is you're plugging in one specific value for theta, one specific value for r, and you're getting a single x and a single y value. Okay. Theta cannot be anything you want. They will tell you what theta has to be. Okay. It's one single number per problem. Now, if you let theta be a variable, which it's not because they give you a specific value, but if you let it be a variable, that's when you start getting all the points on the circle. And that's what we did in parametric. All right, so let's see if we can convert this single point to xy. So that's r, and that's theta. Even if I didn't know, even if I didn't have it labeled, I should know that the second number is an angle because it has a degree symbol. Where it can be a little tricky is if it's in radians. So if you just gave me something like this, technically I don't know if that's an x and a y, or it could be a radius of 2 and an angle of 3 radians. They have to specify that in the directions. They got to tell you what you're working with. Let's start with x. What would be my equation to convert the r and the theta into x here? Gracie? 2 cosine negative 200. And my equation to get the y. Yep.
2 sine negative 200.
2 sine negative 200. Now, if the angle is a multiple of a 30 or a 45, sometimes you get a nice answer. That's not a multiple of either, so we're just going to get decimals here. one thing I want to check first is my mode, make sure I'm in degrees. I'm not, so I'm going to fix that. Okay, and I've got 2 cosine negative 200. It's not super important to close the parenthesis. There's nothing coming after it. But we get negative 1.88. And if you're graphing, you probably don't even need to be that accurate. You really, by hand, can be able to graph to the nearest hundredth on graph paper. Probably not. So, but for calculation purposes, I'll go to 2 decimals. And then negative 2 sine, or 2 sine negative 200, 0.68. So, converting that point to polar, x is negative 1.88, and the y, 0.68. Any questions on that? Okay, so what I've done on the right is I've made a graph. Okay, I got a polar graph, and this is the point that you see in black. You go 2 units to the right, 1, 2, and then you go 200 degrees clockwise. Well, if I go halfway, that's 180. And then if I go to the first line up from there, that's plus 15. So that's 195. And then I just tried to go a little bit past it to get to 200. Okay, so first of all, any questions on how I graph that black point? Okay, now what I'm going to do is I'm going to replace the grid behind it. I'm going to leave the point exactly where it is. So kind of like pulling out the tablecloth here. Everything's going to stay right where it is. I'm just going to replace what's behind the point. And it should look like it's exactly negative 1.88, 0.68. So let's see if this works. I just have to make sure I use the same scale. I think that's the large scale polar, so I need large scale rectangular. Okay. Does that point look like it's at negative 1.9, comma 0.68? Yeah. So that's a way you can check it, like on a computer, or if you need some kind of technology to do it. But just by changing the background behind it, if you use the same scale paper, that should work. All right, so that's one. Let's do this one. So 3 comma 5 pi over 6. Okay, so this one I just want to practice because it's a multiple of 30. So one of the answers is going to come out nice. One of them is going to come out as a decimal, but we're probably going to be able to write it with a square root of 3 or a square root of 2 over 2 or something like that. So I want to make sure we remember those numbers when they come up. So we have r cosine 5 pi over 6, and I put equals because I plan on writing this exact. So probably going to be a square root somewhere. And then r sine 5 pi over 6. So we get 3 cosine 5 pi over 6. And before I hit enter, what do I want to change on my calculator? Yep.
It has to be in radians.
Change it to radians. Okay, you could change 5 pi over 6 to degrees, but then that's one extra step you're doing, and if you do it wrong, then you get the problem wrong. All right, so I get that. To me, I look at negative 2.59, and I'm like, huh? Which decimal? I don't recognize that. And it's because it's being tripled. So let me just look at cosine 5 pi over 6 first. And that I should recognize. Negative 0.866. Does anybody remember what 0.866 was? As a fraction, it has a square root in it. Well, what are the 2 square roots that come up a lot when we did trig with special angles like this? The square root of, yeah, 2 comes up a lot, but that usually comes up in 45-degree angles. That's not a multiple of 45. What's the other square root that comes up? Yeah,
3.
the square root of 3. That's something with the square root of 3. Does anyone remember what you have to do to the square root of 3 to get 0.866?
Is it the square root of 3 over 2?
It's the square root of 3 over 2. So specifically, negative square root 3 over 2, that's this part. Well, yeah, that's that part. Negative square root 3 over 2 times 3. So it's negative square root 3 over 2 times 3. So negative 3 root 3 over 2. Now, if I want, I could type that in and check it and see, do I get negative 2.59? And you will see that I do. Okay, negative 2.59. Okay, but at first, when I saw that, I didn't recognize it. It's because it was the value that I'm familiar with, but it was tripled. That's why I didn't recognize it. All right, if one of them comes out like that, the other one usually comes out fine. So 3 sine 5 pi over 6, and we get 1.5. So the sine of 5 pi over 6 is 1/2 times 3, 1.5. Okay, so just write it as a coordinate. Negative 3 root 3 over 2, comma, 1/2. So that's another thing that'll come up a lot in calculus. Anytime you do trig functions of angles that are multiples of 30 and 45, you're just going to write the answers with root 3s and root 2s. Okay. So that's something that's handy to memorize. Okay. Any question on that? So that was converting something in polar to rectangular. And the last thing is converting back the other way. So now we're in rectangular. And we want to get it in polar. So I have to change an x and a y into, what do we need to have in polar?
R and theta.
We need an r and a theta. So I'm going to draw pretty much the exact same thing I did last time, except this time, the things that I know in the diagram are going to be a little different. So I've got a coordinate, and I know the x and the y value for it. I know the base, I know the height. I need to find r, and let's start with that. How could I get r if I know x and y? Yeah? Yeah, so I'll write that down in a second, but you're going to use Pythagorean theorem to get r. And you also need the angle from the x-axis up to the hypotenuse. What trig function could I use to get theta? It's the only trig function we haven't used yet.
Tangent.
You can use tangent. The tangent of the angle equals opposite over adjacent, and then I'm going to have to get tangent by itself with inverse tangent. Okay, so let me write all that down. Now, the problem with using inverse tangent, if you remember, the range for inverse tangent. Okay, the answer is like if you type in inverse tangent and press enter on the calculator, you're always going to get an answer between negative 90 and 90. So inverse tangent will give you an answer here or here. But what if your coordinate was over there? Inverse tangent by itself would never be able to give you an angle over there. So we have to make a small adjustment if we're here or here, okay, in those quadrants. So the first thing I recommend to do is graph the point and figure out what quadrant you're in. Now, if you can figure out the quadrant, you don't really need to graph it. But the point is, find the quadrant you're in. If you're in quadrants 1 and 4, you're going to do something. If you're in 2 and 3, you're going to do something just slightly different. So we already talked about how to determine theta. You're going to use inverse tangent of y over x. Okay, but the problem, inverse tangent will only give you an answer between negative 90 and 90. So how do you adjust it if you want to be in quadrants 2 and 3? All you have to do is add pi. or 180. So if you're in quadrants 2 or 3, use the formula pi plus inverse tangent y over x. Now, that covers what can happen if you're in quadrants 1, 2, 3, or 4. But that's not everywhere you could be. If you graph something, where else can you be besides within quadrant 1, 2, 3, or 4?
You could be on an axis.
You could be on an axis. And watch what happens if you try to use this formula on an axis. Let's say you had the point right here. What's the x value of that point? 0. The y value, we don't know. Maybe it's up 5, up 6, who cares? But we know the x value is 0. Well, what would happen if you try to fill that in right here? Your x is a 0. What would you end up trying to do? Yeah?
The fraction is undefined.
Yeah, it would be undefined. You can't do that. So when you're on an axis, either one of the 4, you just have to memorize what the answer could be. There's only 4 options. It's either 0, 90, 180, 270. And you might be saying, well, how do I know if it's on an axis? Okay. How do you know? If a coordinate is on an axis, coordinate always has something special about it. Yeah,
X or Y would be 0.
yeah, either the x or the y is 0. So if the x or the y is a 0, you're looking at one of these 4 answers. 0, 90, 180, 270. Otherwise, if you're in a quadrant, there's your formulas. And then the last thing is to find r, which we already said earlier, was the Pythagorean theorem. Technically, if you want to do r first, you can. R and theta are separate. So whichever one you want to do first. Yeah?
So, I don't know if this would ever actually come up, but if the point was in the origin and it wanted us to write the point as polar, what would we say for the angle? Because it could be anything with a radius of 0.
Yeah, I won't give you a point at the origin. But yeah, technically in polar, you could write 0, comma, n, where n is any real number. Yeah. So there's an infinite amount of ways to write a point in polar that's at the origin. And technically, there's an infinite amount of ways to write every point in polar, but I consider them 4 basic ways. But the origin is kind of an exception to that. It does really have an infinite amount of ways to write it. Ask Mr. Bad then, see what he says. All right, so any questions on the steps for converting a point from rectangular to polar? Right, let's try an example. Okay, so we've got the point 3, -5. All right, so what do you want to do first? Do you want to find the radius first or the angle? Trevor, what do you want to do?
Radius.
Okay, so let's do the radius. I don't really have to graph it, but you just have to know the quadrant. What quadrant am I in there? Yep, right 3, down 4. In quadrant 4, Leo, is that the one where I add the 180? Or no, I don't have to. No. So it's just inverse tangent of y over x. Now, let's say that was -5 over, I don't know, 12. Or no, let's do 10. If you have a fraction you can reduce, it's up to you. You can reduce it. I don't bother, because I'm just going to type it into the calculator anyway. Reducing it, just one more thing you could do wrong. All right, you could do this in radians or degrees. I'll do it in degrees. And I'm expecting a negative angle, because I'm in quadrant 4. Okay. So inverse tangent of -5 over 3. So we get an angle of -59. Now, if you're thinking, well, couldn't you write it as a positive angle? Sure. There's 4 ways to write this. Negative angle, positive angle, negative radius, positive radius. I'm not going to go through all 4 ways. Okay. I'll just do it the way that came up originally, -59.04. there's one way I can write my angle. And now my radius, I'm going to use Pythagorean theorem. So r squared equals x squared plus y squared. Too many steps at once. So we get 9 plus 25. And that means my radius is how much? You don't have to do it as a decimal. Yep. Just the square root of 34. Just like always, when you get a root, make sure you reduce it as much as you can. Like if it was the square root of 20, I would expect to see, what's that, 4 times 2 root 5. Okay? Okay. So one way you can write this answer is r, comma, theta. And there's 3 other ways you can write it. I already showed you one of the other angles you could use, 300.96. Any questions on that one? All right, let's look at this one, 0.6. Now this one shouldn't be as bad as the last one. Not that the last one was really bad, but this should be quicker. What's my radius? If you measure the distance from the origin to the point 0.6, yeah? 6. It's not at an angle. The only time you're going to use Pythagorean theorem is when you need a hypotenuse. You're right on the axis. So 0.6. Because you're on an axis, we should already know the angle. It's just up 6. So what's the angle? Yep. 90. So your answer, r, comma, theta. Again, that's one of 4 ways you could write the answer. Okay, any questions on that? So we didn't really use graphing calculator much at all today. We didn't get into equations in polar. We just stuck with coordinates. Tomorrow we'll get into equations in polar, how to convert between polar and parametric, and we'll name a few special graphs. We'll look at spirals. We'll look at what's called a cardioid. We'll look at a shape that kind of looks like a flower with any number of petals you want to put on it. And I think that's it. So we'll look at just some special shapes. And that'll end our unit on parametric and polar graphing. Okay, just a quick kind of 3-day thing. Okay, so homework tonight on 492. It's 1 through 16 all. Okay, just as a reminder, I'll be after school tomorrow for extra help. I know I said that I was going to go back to Thursdays before April vacation, but one of the classes that I take at night was canceled due to snow on a Thursday. We didn't have school a month or 2 ago. So we're making that up after April vacation. So I'll go back to Thursdays, not the week we come back, but the week after.